Hello, everybody. We are back for another fun-filled math video, I hope. So we're looking at quadratic functions, section 2.3 in the business math book. And just to basically let you know what these look like, most of you have probably seen some of them before, but kind of the generic format for them looks like y equals ax squared plus bx plus c, and you've probably seen something like that before. We're talking about A, B, and C are just real numbers. So they're going to be actual coefficients that we can manipulate. And that's, if you know about the quadratic formula, if you've used that guy before, then you've seen how you manipulate that A, B, and C. At one point I'll go through that, but that's actually not part of this course. Hopefully you've seen it before, and when I do that with you, it'll just be a fast review. That's my hope. And the one thing that people normally know is that whenever we talk about quadratic functions, that ax squared plus bx plus c, that if I were to graph these things, they would look like parabolas, right? Okay. And if you don't remember, a parabola is just kind of a U-shaped graph. If the a is positive or greater than 0, then it opens upward. If the a is negative or less than 0, then it opens downward. Real quickly, what if a is 0? Then that term completely goes away, right? And then we just have bx plus c, and that guy would be linear. We already talked about solving linear equations, right? Now we're talking quadratics. So you can't have a 0 for the a. A cannot equal 0. Okay, you'll see this in the textbooks. You'll see like they make this little stipulation, a can't be 0. And people go, why? I don't understand. Why not? Okay, so that's why not. Because if a was 0, then we wouldn't have the x squared term. It's this x squared term that makes it quadratic. Basically, the idea here, this guy would be a positive leading coefficient, and this guy would be a negative leading coefficient, or the a guy. That's the first coefficient when you have this in the descending order. X squared comes first, then the x, then no x's, right? Okay, so whenever I look at that, I say, oh, the positive guy. What I used to say whenever I taught high school was the positive guy has a smiley face, right? He's always positive. And the negative guy, he has a frowny face. So if that helps you remember, that's great. If not, just whatever helps you out, make sure you know the difference. What we're going to be looking for at some point as we work through this, what we see is, okay, the largest exponent on the x, or any variable that we have, but normally we deal with x, is a 2. And at most, these graphs go in 2 directions. Okay, and that is not by coincidence. Okay, so here I would go down and then up. That's 2 directions, 1, 2. And then here I would go up and then down. That is also 2 directions. So that is completely and totally tied to the fact that our variable here, which is the x guy, is a 2, right? So that is absolutely what's going on. The other thing that we'll start looking for is here, this guy, the turning point for the parabola. We didn't have turning points when we dealt with linear, right? But now we have a turning point, and the turning point is the vertex. That's what we call it. I'm sure you've heard that terminology before, right? And in this case, because it's 1, 2, there's 2 directions, there's only one turning point, right? 1, 2, that's only one turning point. Sorry, I left out the word point. Turning, I'm so sorry, guys. Turning point equals the vertex. Sorry about that. Okay, so the turning point equals the vertex. So it is either a maximum which is the highest point. Okay. Out of these two, the one with the maximum is this one. The negative guy has a max, right? Max for maximum. Okay. So it has a highest point. It is the turning point, is its maximum point. Or it could have a minimum. And we're thinking just like in our English language, that's the minimum is the lowest point, right? Okay. And that would be right here. This guy goes down and then up. This point right here is the turning point, and that is the very smallest point on the graph, right? The very lowest, I guess I should say, point. Okay. So that's the two different things we're going to have whenever we're dealing with parabolas here. You're either going to have a maximum or a minimum, and that's going to be the vertex. And it's important to know that it is at most one turning point. Okay, that's the most. Along with that, let me just go ahead and throw this in. Many of you know that whenever I have functions with x squared quadratics, whenever I have one of those, have at most, and again, that's that word at most, two solutions. Okay, so if I go to solve one of these quadratic guys, and we will here in a little bit, and it's going to have at most two solutions, what do you think that 2 goes with? In my head, I hear you saying, it's the exponent, Dr. Webster. And you're right. Okay, so the exponent, the largest possible exponent in a function on the variable that we're dealing with, has basically controls how many possible solutions I have. So for our purposes, these are going to be called solutions. You might have heard them before called roots. You might have heard them called zeros, okay, which is also solutions. A very common one in algebra is x-intercepts. That's the one we're probably going to deal with a lot in this course. You're going to see it repeatedly. But anytime I use some of those terminologies, especially when we're talking about quadratics, if we're looking at a quadratic function and we know that we're trying to find the solution or the root or the x-intercept, those kinds of things, the most we can have is 2. That's the most. Okay. And it absolutely is because of the exponent. That's not a coincidence. Okay. And later on, when we get into the calculus part of this stuff, we'll kind of see how that works and why. But it is absolutely tied to that. So don't think, oh, I don't know why that's happening. It's happening because of the exponent. Okay. Now, when I say at most 2 x-intercepts, that means you could have 1 x-intercept. You could have 0 intercepts, right? But these quadratics, they only have 2, 1, or none. Okay. That's all you can have. At most 2. That's what I mean. I know I've said it like 5 times. I'm sorry. Okay. So what are we going to do with these things? Well, the first thing that most people who are dealing with quadratics figure out how to do is how to find the x and the y intercepts. Okay, and this will be, of course, in your homework. Okay, so you're going to see stuff where it'll say find the x-intercept, find the y-intercept. Well, whenever I'm talking about a graph here, let me just throw this graph right here. We're just going to make a pretty parabola. Okay, it's not in the center. I'm trying to offset it a little bit. Here's my x's and here's my y's, right? Okay, so I've got a parabola there. And if we wanted to talk about the x-intercepts, actually, I'm sorry. Let me draw a different graph because I want it to have both. I apologize. I'm just going to make it a little wider. The x and the y. Okay, there we go. So if I want to talk about the x-intercepts, sure enough, I see x-intercepts are where you cross the x-axis, right? X-intercepts are where the graph crosses the x-axis. Okay. Absolutely. And right here in this particular picture, you can see that I'm crossing it in two spots, right? Okay. The same was true up here. We had two x-intercepts. Okay. And so when I talk about how I graph these things, like for instance, this point over here, that point is probably something like the x is a 1, the y equals 0. Let me put a couple of spots here. 1, 2, 3. Okay, so this point, it's an x-intercept also, right? It's going to be the x is 3, the y is a 0, right? And so anytime I talk about x-intercepts, that's where it crosses the x-axis. That's where y equals 0. Okay, all of that goes together. So if I ask you to find x-intercepts, what are you going to do? And in my head, I hear you saying, we're going to plug in 0 for y. And that's exactly what you're going to do. Okay. Plug in 0 for y. Okay. And that happens anytime you want to find the x-intercept. Okay. And so that all goes together. And then what about the y-intercepts? Okay. Very similar, but they're where the graph what? It's where the graph crosses the y-axis. I do have these conversations with myself when there are no students present to answer. Okay, so y-intercepts are where the graph crosses the y-axis. So again, let's look right here. What if this is the point, that point right there? Let me put some values in there. What's that point? We didn't go any left or right on the x-axis, right? Instead, we just went up 2. Okay, so for the x-intercepts, I had y equals 0, but what do we see here? We have x equals 0, right? Okay, x equals 0. That's what I saw. Now, the reason I didn't stick with this graph is because we'd have to come way up here before we found a y-axis, y-intercept, where this graph hits the y-axis would be way up there. So that's why I made it a little wider and went with this one. Sorry about that. Okay, so we want x to be 0. And if earlier we wanted y equals 0, we plugged in 0 for y. What are we doing now? I hear plug in 0 for x. And that's exactly what I'm thinking we should do. Okay, so there's a process whenever they tell you, and the directions will say something like find the x-intercepts, find the y-intercepts, find the x and y-intercepts, something like that. So you're going to see these directions like in the homework, on the test, things like that. And you're going to know, okay, if they want the x-intercept, it's the opposite variable, right? We want x-intercept, we plug in 0 for y. We want the y-intercept, we plug in 0 for x. So it's the other variable that's going to be 0. Okay. All right. So there we go with that. Let me scoot on down and get a new sheet of paper. And we're going to look at an example. Yay. Examples are our friend. Okay. It'll say g of x equals 2x squared minus 5x minus 5. And the directions will look like this. Find the x and y intercepts. Find the vertex, which I haven't told you how we're going to do that yet, but we'll get there. And then graph, which we'll talk about that also. Okay. So before we get going with this guy, I want you to examine this equation right here. And just for a second, pause the video or whatever you need to do. Think to yourself, what do I know just looking at this equation? I need to know a couple of things, okay? So what do I know just from staring at that? Push pause if you need to. Okay, what I think I know is two things. This is g of x. That's the function notation, right? So right off the bat, I'm being nice and I'm telling you this is a function. Okay. And most of the stuff we'll deal with in this class will be functions. Okay. But it's clear to me this is a function. I don't have to go check it. I don't have to solve for y. I don't have to do any of that kind of stuff. Okay. And the second thing I know is the variable here is x because it says my function g has a variable x. And I've got x squared, right? I also have an x, but we don't care about him right now. We care about the largest exponent. And whenever I see that x squared, this is the point of today's lesson, I think, hey, that guy's quadratic. Okay, so those are the two things we know. I'm also going to throw out this other one, but if you didn't see this to begin with, it's okay. Here's my leading term. This is in descending exponent form on the x's. That would be my leading coefficient, the 2. And what's the sign out in front of it? SIGN. Is it positive or negative? This guy's positive, right? Okay. So because it's positive, that tells me it's a happy face. It's positive, right? Okay, so it's smiling. It's an upward facing parabola. That's what we call it. So that's I have a good idea already what this graph looks like. It's quadratic. That looks like that, and it looks something like that because it's positive. The first leading coefficient. Okay. The other two coefficients, the other two numbers in there, those are not positive, but we don't care about those for the overall shape of the graph. That's determined by the leading term. Okay, so let's get to it. We need to find the x-intercepts. And when we do that, we said we were going to plug in 0 for y. Okay. Now I'm looking at this guy and I say, hey, I don't see a y up there. Why is there not a y? And the reason there's not a y is because they gave this to me in function notation. But we know that the function notation, this guy over here, the g of x, that's the same as the y. So if you need to, you can mark that guy out. If you don't need to, you can just say, oh, my y's on that side. No problem. Okay. But if you need to, you can mark that guy out. Now you have y equals 2x squared minus 5x minus 5. And you're plugging in 0 for y. So here's my y guy. 0 equals 2x squared minus 5x minus 5. All right. So I'll come back to the directions in a second, but I'm scooting up. Okay. Now, what about this guy? Ooh, okay. We look at this and we think, man, this is where if this thing would factor, we've made you do the factoring review, right? So hopefully you know what's going on where. If this thing would factor, that would be awesome. However, it doesn't factor, okay? And you can run through the AC method or the box method or trial and error, whatever you do. But I'm looking at this thing going, doesn't factor. Okay. It's just not going to be nice for me. And so I need some other method of solving this guy for x. I need to figure out what my two x-intercepts are, right? Okay. I probably should have started y'all with a nicer equation that would factor, but this one doesn't. I'm sorry about that. I didn't pick the example. It was what came out of the book. So anyway, I'm looking at this and I'm going, hey, find the x-intercepts, solve for x. I can't factor. So when I can't factor, I'm going to come off to the side and I'm going to use what's called the quadratic formula. Okay. Again, I hope that you know the quadratic formula, that it's somewhere in the back of your brain rolling around. If it's not, then you need to stop and take some time to make sure you remember the quadratic formula. So remembering that we have, let me back up a step, y equals ax squared plus bx plus c. Okay, that's what we have. That's the general form of the equation, of the quadratic equation, right? So there's something called the quadratic formula that says x equals negative b plus or minus b squared minus 4ac all over 2a. Okay. Now, almost certainly this will be given to you on any exams that we take, but really, once you've played with it enough, once you've used it in enough equations, enough examples, you should know this guy because he's just in the back there. Okay, so we're going to figure out how in the world are we going to use this quadratic formula right here. And again, if this seems new to you, make sure you go and learn this because it should not be new. Okay, so here I have this guy as my a because he's attached to the x squared. This guy is my b because he's attached to the x, right? B is attached to x. And this term at the very back is a constant, he's c. Okay, so I'm going to write that down to the side. A is 2, b is -5, c is -5. I like to write those down. It didn't take me but about 2 or 3 seconds to write that down, but now I can see them and I can use these things to plug into where I have the quadratic formula. Okay, so using the quadratic formula, x equals negative from the formula, and the b is a -5, plus or minus the square root of b squared. Now be careful because it's the entire b squared, so you might want to put parentheses. There's a difference between -5 in parentheses squared and just -5 squared. And if you're using your calculator to figure this stuff out for you and you don't put the parentheses, then your calculator will tell you it's -25. Okay. But we know c squared is, I'm sorry, it's because they're both the same. B squared is -5 times -5, and a negative times a negative is a positive. So when I do this math, that's going to be a positive 25. Okay. Minus from the formula, 4 from the formula. The A is a 2, and the C is a -5. I'm kind of out of space. I apologize. Okay, so all over there's a 2 in the formula, and the A is a 2. Okay. So I just plugged it in. We call it plug and chug in math. Okay, so normally I find students are pretty good at plugging and chugging as long as they know what they're supposed to be doing. Like if you know to use the quadratic formula here, you're probably pretty good. So x equals negative times a negative is a positive 5 plus or minus the square root of. I just said -5 times -5 is positive 25. This is a -4 times 2. That's -8. -8 times negative, this was a -5. Negative and a negative is positive. 8 times 5 is 40. All over 2 times 2 is 4. Okay. And then last here, we're not finished yet, but I just want to get my get this simplified. I'm going to clean up what's inside of this quadratic. So 5 plus or minus square root of 65 all over 4. Okay. So there's a little bit of a problem because the square root of 65 is not a pretty number. Okay. If it was square root of 64, that would be 8, right? Okay. But it's not. It's square root of 65. So it's 8.06. The decimal keeps on going on, but I feel comfortable rounding it to 2 decimal places behind the decimal point. So I'm going to call it 8.06. If you know how, you can just keep that decimal in your calculator and work with it from there, and I'm good with that. Look right here. The formula has this plus or minus in it, right? That's how I'm going to get 2 solutions. So I've got x equals 5 plus, and I'm going to put in this 8.06 for square root of 65 over 4, or the minus. X equals 5 minus, again, the square root of 65 is 8.06, right? All over 4. Okay, so I've got 2 different answers, and right here is where they will completely diverge from each other, which is fine. just know that the plus 8 is going to, this is going to be a positive number. The 5 minus the 8, that's going to be a negative number, right? So I'm going to do it right here on my calculator. 5 plus 8.06. I'm just going to say, if you're not sure and you're not using parentheses, hit equals here. That tells me exactly what's on the top. So this is x equals 13.06 over 4. And then divide by the 4, and that gives me x equals 3.265. Okay, that's one of my solutions. If you're not sure about that, the reason I say be careful with it is because if you do 5 plus 8.06 divide by 4, what do you think is going to happen? I'm not going to get the same answer. And the reason why is because it's going to divide the 8.06 divided by 4. Okay. It's going to get a little bit more than 2. And then it's going to add that to 5. It's all about your order of operations, right? So 2 something plus 5 is 7. So you really have to know your order of operations. You need to do the entire top. I think there's parentheses here if you must. If you're using your calculator and you're not clear about it, think parentheses, or just do the entire top and then do the entire bottom. Okay. So over here, I've got 5 minus 8.06. I'm going to get an answer there. That's negative 3.06 divided by 4. And I'm getting x equals negative 0.765. Okay, so that's almost a negative 1. These are way different answers, so you can't just sit there and say plus or minus. Okay, again, if you don't put the parentheses and you don't hit enter there, you're not getting the same answer. Okay, so be sure you do all the stuff on top, all the stuff on bottom, and then you divide at the end. Okay, it's like grouping symbols where the top is all grouped together and the bottom is all grouped together. That's what this fraction bar does for me here. Okay. All right, cool beans. Where are we? Let's get rid of that guy. I'm going to get a new sheet of paper. That was the x-intercept, right? That's what we did, find the x-intercept. We also need to find the y-intercept. Okay, so the original equation, let me throw it right here so we're not losing track. This is kind of a long problem. It's okay. We also, this is still part A, need y-intercepts. Normally people like the y-intercepts better because it's plug in 0 for x. And when I plug in 0 for x, things go away. So this is actually the easier of the two processes. I don't have to factor. I don't have to use quadratic formula. I'm just going to plug in 0 for x to get my y-intercept. What's 0 squared? 0 times 0 is 0. 0 times 2 is 0. That goes away. 0 times 5 is 0. That goes away. Does it matter if it's positive or negative 0? No, because it's still 0. So all we get here left over is negative 5. Right? So my y-intercept is y equals negative 5. Okay. Let me stop and take just a moment here. First of all, is everybody okay with that? I hope you are. If not, go back and look at it again. Okay. Notice that when I did my x-intercepts, I did x equals this number. X equals this number. We have to be clear when we do this, and you will lose points on a test if you don't do this. This is y equals this number, right? There are two ways to write these intercepts. You can either do as I've done, x equals, or you can write them as a point. And what point would we use here? Here is my x value. And what was my y value? Come way back here. We plugged in 0 for y, right? Y was 0. So remember, this is supposed to be an x-intercept, right? It's supposed to hit the x-axis. And the only way that happens is if y equals 0. Okay, so come back one more page. I'm going to show you this again. Remember, we had it right here. All of my x-intercepts, if I write them as a coordinated point, okay, coordinated pair, we call it a point. They have 0 for the y value. So this guy would be negative 0.765, comma, 0. So you have two options when entering these. And normally in my math lab, it'll say, give this as a point, or it'll say, write x equals, or it might even say x equals, and you just have to enter whatever the number is, okay? But what you can't do on a test, and I see this a lot, so that's why I'm warning you, you can't just say 3.265. Okay. If you just say 3.265, you're probably going to lose a point because I don't know what 3.265 means. I need to know this is my x value. Or here, if you put it as a point, a coordinated pair, you're telling me this is my x value. This is definitely a y-intercept, or I'm sorry, this is definitely an x-intercept because the y is 0, right? I can tell that. Okay. Same thing here. We got our y-intercept. You can tell me y equals, or what's the x value here? Come back to our little graph. The x value on my y-intercepts is a 0, right? Okay, that's how I got here. I plugged in a 0 for x. So if you want to give me a point here, that's fine. You can say 0, comma, negative 5, right? That's okay. You can also say y equals negative 5. What you can't do is just say negative 5 with no context at all. You will lose points. I'm warning you. Please don't do it. Okay? All right. There we go with that. That's my x-intercepts and my y-intercepts. That was the A part. Part B says find the vertex. Okay, for the same equation. So let's talk about the vertex. Find the vertex. Let me put the directions. Okay. Interesting thing happens whenever you look at quadratic formula. Let me throw that equation back up here. The formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what happens whenever I'm looking at this thing is the graph, this isn't the graph for this equation, but the graph, whenever I'm looking at this, here's my vertex, right? Okay, down here. We already determined this one is an upward facing parabola, right? Because it's got a positive leading coefficient. So it's going to look something like this. The point I'm finding, the point I'm trying to find is the minimum. And what happens here is basically when I find that vertex, all this stuff back here is 0. Okay, whenever I'm looking at the vertex. So, and we'll talk a little bit more about that probably when we get into the calculus of this, but basically all of this would be a 0. And so we get this little equation that comes out of the quadratic formula that says, hey, if all that stuff in the back is a 0, then we can find the vertex very easily by just finding x equals negative b over 2a. So the formula for a vertex of a parabola actually comes right out of this quadratic formula, and it's x equals negative b over 2a. I'm just going to kind of warn you, I like to give matching sheets for the formulas. So they'll all be there. So you're not going to have to come up with this out of the blue, but you'll have to know which one's which. You'll have to be able to go, oh, that one's the one I use for the vertex. This one's the one that's the quadratic formula, right? So absolutely, you'll have to look at that and see, right? Okay, so that's the formula we're going to use whenever we are looking for the vertex. So here we go. Our equation was here. Remember, A equals 2, B equals -5, C equals -5. I said it, I didn't write it. B equals -5, C equals -5. So I don't actually need the C here. All I need is negative B over 2A when I go to find the vertex. And the negative comes from the formula. And the B is still a -5, just like when we plugged into the quadratic formula earlier. The 2 comes from the formula. And the A is still a 2 in this situation, right? And every quadratic formula, I'm going to have a different A, a different B, a different C. I just pick the one that I have in that situation and plug those numbers in, right? Plug and chug. A negative of a negative is a positive. This is a 5. A 2 times a 2 is a 4. 5 over 4, or if you like to make that into a mixed number, you can. 1 1/4, that's okay. I normally leave things like this, even though it's an improper fraction. I know sometimes math teachers drill into our students, don't leave it as an improper fraction, but for our purposes, sometimes -5 over 4 works nicely. So I don't care if you leave things as -5 over 4. That's fine by me. Okay. This is formula vertex of a formula, the x value, right? X equals negative b over 2a. So what I've got right here is x equals 5 over 4. I'm still looking for my vertex, right? Okay, it's a point on the graph. It's the turning point, right? It's this spot right here, the minimum. Okay, that's not a point. Okay, be careful with this. That is an x value. What we just found, we use this vertex, it tells me the x value. So, how do I find the y value whenever I know an x value? And the answer is to find the y value of the vertex, plug in the x value into the original formula. I'm sorry, original equation is what I'm after. It's not a formula. Okay, so if I want the y value, I've got an x value. I just need to plug it in, right? Okay, so again, one more time. Well, probably one more time in a minute. Y equals -2. The x that I'm going to use is 5 over 4. And then that's going to be squared. And then the equation was -5 times the x. We're putting in 5 over 4 because that's what I just found, -5. Okay, so go back to your original equation, plug that guy in. Okay, so we can absolutely do that. Again, if you want 1 and a fourth, you can, but this is one of those cases like right here. I think it's much cleaner for me to use the 5/4. Why? Because when I come in here and I want to square this guy because it's being squared, right? Y equals -2 times. The rule for squaring a fraction is square the top. Well, 5 squared is 25. Square the bottom. 4 squared is 16. So if I have it like that, it's actually much nicer to deal with right here as a fraction. Some people like to make it into a decimal, like 1.25. I don't like that either. Then I'm having to use my calculator to do that. I can do 5 squared in my head, and I can do 4 squared in my head. Okay. Be careful when you get over here when you're trying to simplify this. 5 is really, or -5 is really -5 over 1. And the rule for multiplying fractions, straight across the top, straight across the bottom. And the reason why I make it a 5 over 1 here is because I want to have that denominator so I can multiply them, right? This asterisk is a multiplication symbol. Okay, so I've got minus because it's sitting here. 5 times 5 is 25. 1 times 4 is 4. And then minus a 5, right? Okay. So if you want to, again, you can always go and use your calculator here and get some decimal, but I'm hoping that you're willing to do some work with your fractions. Hopefully everybody knows how to add fractions or multiply fractions here. So let me just do this real quickly. I'm going to multiply the 2 through, again, it's really a negative 2 over 1, right? So y equals, let me multiply the top times the top. Negative 2 times 25 is negative 50. Bottom times the bottom is 1 over 16, or 1 times 16, so it's 16. Okay, minus, okay, common denominators. I've got a 16 and a 4, and I want a common denominator. I have to have common denominators anytime I want to add or subtract fractions. So I see, hey, if I multiply this 4 times another 4, I'll get 16. Then I'll have a common denominator, right? Okay, so I'm going to multiply that, but the rule says if I multiply the bottom times a 4, I have to also multiply the top by a 4, right? So 25 times 4 is 100. It's not bad math. I can do it in my head. Minus 5. Okay. Now, again, I would love it if you would just go ahead and stick it out with this fraction thing. If you're like, I can't do that, then at some point you can dig out your calculator. I'll get you a decimal approximation in a minute. I'm going to finish this one using the fractions, because I think it's very doable. I think we can handle this. I just want to check real quickly that I got all my negatives right. Yeah, because this was a negative 5 times a positive 5, 4. So this is a negative. This was positive times a negative. They're all negative at this point. I'm just checking, so my math is right. Negative 15 minus 100 is negative 150 over 16. And I'm going to kind of cheat just a tiny bit here. It's minus 5. But again, that's over 1, so I can make that a 16. I had to multiply by 16 there. Let's see, the math there is that, I think it's 90. 5 times 6 is 30, carry the 3. Oh, 80. 5, 80. Okay, so I think I've got y equals a negative 230 over 16. Okay, that's what I think it is. We're going to grab the calculator and get us a decimal approximation for both of these. So here we were, y'all know already if you wanted to, x could equal 1.25. That one's not so bad. But let's see what we get whenever I deal with this one. 230 divided by 16. Of course, it's a negative. Hang on. I don't think that's the right answer, so let me check. I think I must have some negatives off somewhere. Oh, you know what? It was right here at the beginning. Dang it. And see, this is the problem with not having class, is people can't tell me these things. This was a positive 2, right? I'm so sorry, guys. See, we all make mistakes. It's okay. Positive 2, positive 2. That's going to make that a positive number. It's not bad. Don't worry. Don't stress out on me. I apologize. So let me come back right here. Start again. Y equals, it was a positive 50 over 16. A minus 100 over 16, and a minus 5 over 1. Okay, sorry about that. See, that's why I checked my negative. I must have known something was wrong, but I just didn't realize I copied wrong here. So this guy's a positive. I apologize. I was like, that doesn't look right. Okay, 50 minus 100 is negative 50 over 16, and it's a minus, what did I just say, 80 over 16. Let me check that math real quickly. Oh, 5 times 16. Yep, it's 80. Okay, now let's try it again. Y equals negative 130 over 16. Let's check it on my calculator. Oops, no, 30 over 16. That looks better. Negative 8.125. All right. So either one of those answers would be absolutely fine. If you were looking for this point as the vertex, we have this. my vertex is 5/4 -130 over 16 or 1.25 -8.125. Oops, there you go. All right, so that's what you would be doing here. Either one of those is perfectly acceptable. Um, there you go. There's your vertex. Okay, and then we have one more step. I know this is really like 3 problems in one. I'm sorry it's taking so long for this one example. The last step was graph this sucker, right? So let's put it all together. C is graph. Let's see if we can stick it all together here. Okay, so I've got my coordinates pair, my coordinate system. I've got an X, I've got a Y, and here's the stuff I know. I have an x-intercept at 3.265 and 0. So 1, 2, 3, 4. 3.265 and 0. Here's the cool part. I don't have to have exactly that point. If you want to, you can try to make it as close to 3 as possible or whatever. I just need to know basically where it is, okay? The other x-intercept is at -7.65. And I said earlier, that's almost -1, right? Okay, so there's my x-intercepts. My y-intercept was at -5. So that was y equals -5. That's right there. So we've got 3 points on the graph. We know it's going to make a parabola, so it's going to look something like that. The deal is I really want to know exactly where it's turning, right? So that's why we went through the effort of finding our vertex. So it's up here, and it's at 1.25, somewhere in there, and -8. So I got to keep on going down. Okay, -8. So it's a little bit bigger than -8, a little bit bigger than 1.25. So it's right in there somewhere. That's my turning point or my vertex, right? Okay. And then basically, I'm going to try to graph this guy, connect the dots, so to speak, make it curvy. Try not to make it like a harsh corner down here. It should be curving, should be a U shape, not a V. So it's not this, right? So don't do that. Okay. We want it to be a U shape. So there we have that. And I think we are good there. All right. Put my calculator away. Okay, so that's the basic graph. The graphing part was actually very not bad once we knew everything else, right? So not bad at all. Okay. You try one. Whew. There we go. That was a lot, right? Okay. So here you go. Hang on a second. I'm sorry. All right, sorry, I had to pause you so I could make up a nice, pretty example. I noticed that the other example in the book, the very next one, is also not a pretty answer. So I'll give you that one to work on in a second. You can play with it, but for right now, I'm gonna be like, okay. Did I even finish that? That's interesting. Okay, so let's try one. I think you should be able to factor this one. So here we go. Y equals 6x squared minus 9x minus 105. Again, I see this as a x squared, so it's quadratic. This is going to be a parabola. It's positive out in front, so that's going to be an upward facing parabola again. So we have a basic idea of what this guy looks like. And then I'm going to say, okay, we ought to be able to work this guy out and see what we get. So let's try it and see. X-intercepts. Find the x-intercepts. And the y-intercepts. Let's do the y-intercept first. That'll make it nicer. y-intercept. Plug in what? Plug in 0 for x, Dr. Webster. That's what I hear. Okay, so I wish this was a face-to-face class, but here we go. All right, plug in 0 for x. So I come up here, I say y equals 6 times. Instead of this x, I'm going to put in a 0. Squared minus 9 times. Instead of that x, I'm going to put in a 0. Minus 105. Okay. Again, this makes life nice for me because 0 squared is 0 times 6 is 0. 9 times 0 is 0. So I get a negative 105. Okay. So x equals negative 105, or your point is 0, negative 105, right? Okay. So it's kind of a big number, but it's okay. That's actually a prettier number than what we just did a minute ago, right? So we've got our y-intercept. We're going to do x-intercepts. Let me write it again here. There's my original equation, and we're going to do x-intercepts. Okay. Still part A. And how do we do that? Every time you go to find an intercept or something, I want you to ask yourself, how do I do that? And I want you to hear yourself saying, plug in 0 for y. Maybe that'll make you remember. Okay, so this is the part where last time we had to use quadratic formula. I plug in 0 equals 6x squared minus 9x minus 105. And hopefully you can run through this factoring pretty quickly. That's why we did a factoring review, right? If you can't, then you're going to be like, oh man, this stinks. Okay, which is fine, but you're going to have to, work it out here. Okay, so, oh, interesting. Okay, so let's look at it. I'm looking here and I see everything's divisible by 3. So I'm going to factor that 3 out, so that I'll deal with smaller numbers in here, right? How did I know 105 is divisible by 3? Because the rule for divisible by 3 is add up the digits. 1 plus 0 is 1, plus 5 is 6. If your sum is divisible by 3, then so is the number, right? And look at that. 105 divided by 3 is a 35. So that's the rule for divisibility. You could have also looked and gone, well, I know 6 is divisible by 3 and 9 is divisible by 3. So maybe 105 is also, but definitely they are. Okay, we pull the 3 out. It's a factor sitting out there by itself. And then I look at this guy and I say, well, 2x squared goes 2x and 2x. I need factors of 35, where one of them is a negative guy because it's a positive times a negative gives me the 35, right? They need to add up to negative 3x, and I think I'm looking at 5 and 7 here, where it's a negative 5 and a positive 7. Now, I'm doing trial and error here. 2x squared plus 14x. Oh, did I mess that up? Ooh, I did. Hang on. See, that's why it's called trial and error. Okay, let's try that again. 2x squared. 2x squared minus 10x plus 7x. That's the minus 3x minus 35. Okay. So that is how that guy factors. Now, I'm old school and I do a lot of my factoring by trial and error. If you can't do that, then that's why we had you do the factoring review. This is not going to go away. You're going to be factoring all semester long. That's why I put that at the beginning of the semester. You've got to be able to factor. So if you can't do that, then you're going to go back and you're going to use the AC method or the box method or whatever you need to do so that you can get right here. Okay. If you can't do that, you can always use the quadratic formula. We had that earlier. Um, it's gonna take you a lot longer because you gotta use that formula, you gotta plug it in, you gotta clean it up and make it simplified. This didn't take me very long to go 1, 2, 3, right? So, do what you wanna do. Okay, solve this thing. Well, I know if this times this equals 0, then one of these guys has to be equal to 0, right? So either 3 equals 0 or 2x plus 7 equals 0 or x minus 5 equals 0, right? That's called the zero product rule. If these three things are multiplied together and give you 0, one of them's got to be 0, right? 3 times what gives me 0? It has to be a 0. Or this thing times what? This has to be a 0. One of them has to be a 0. Now, what do we think about 3 equals 0? That's not true. Okay, so now I look over here and I've got a nice linear equation, right? I can solve this guy. We did that last week. 2x equals negative 7. X equals negative 7 over 2, right? Or I just need to add this 5 over, right? I didn't write my little steps here. Sorry. That's what I did. Okay, so x equals a positive 5. So you get two answers here. There are two solutions, and that's the maximum number for a quadratic, right? You can have up to 2 x-intercepts. You can leave it just like this, or you can make it into a coordinated pair or a point, okay? It's negative 7 halves and a 0, or 5 and a 0. Absolutely. There are your two x-intercepts, okay? All right, so we got our y-intercept, we've got our x-intercept. We need to kind of work through this guy and see what we get for the vertex. B was find the vertex. Okay, remember we use x equals negative b over 2a. That's what we're going to use here to find my x value of my vertex. Okay, what's my a? Here's my x squared guy. It's a 6. A equals 6. What's my b? Here's my b guy. Remember, it's not the whole term. It's just the coefficient in front of the variable. So b equals negative 9. And my c guy is always the constant. C for constant there. Sitting out by himself, negative 105. All right. So those are the numbers I'm going to use in here. I'm just looking for the vertex. So x equals negative from the formula, and the b is a negative 9 over 2 from the formula, and the a is a 6. Negative and a negative is a positive. That's positive 9 on the top. 2 times 6 is 12. I see they're both reduced by or divisible by 3. So I'm going to go ahead and say 9 divided by 3 is 3. 12 divided by 3 is 4. 3/4. Okay, so this is a 3/4. If I want the y value, remember what we do. We go back to the original. Y equals 6 times, and we plug in our x value. 3/4 squared minus 9 times 3/4 minus 105. Okay. Again, y equals 6 times. This is 9 over 16. Square the top, square the bottom. And again, I can write both of those over 1. So minus 9 times 3 is 27. 1 times 4 is 4, minus a 105. Let me make that one step better. Y equals 6 times 9 is 54 over 1 times 16 is 16. Okay. Again, we can get the common denominator. Again, you can go ahead and do this on the calculator just for time's sake because I feel like I'm running out of time. I'm going to punch this guy on the calculator. 3.375. Oops. Minus 6.75 minus a 105. And when I punch that all in, I get y equals negative 108.375. Now, this is really big numbers again, but remember, this is the vertex. This is the turning point. So it is, let me make the x value into a decimal. My vertex is 3/4, which is 0.75. And the y value is negative 108.375. Okay, so now I'm seeing where, hey, these numbers are getting really pretty big, right? It starts out with the 105 in the original function or original equation, right? Had a really big number. So I just look at it and go, hey, okay, I've got these points. I need to graph it. That's the last step here. That's part C. And just for the interest of time, because I know that this negative 108 is going to be a big, big guy, right? I'm going to use my graphing calculator to graph this guy so we see it. And then you could sketch it out. Let's see what he looks like. Y equals 6. I'm using the X button, which is up here. If you have a TI 83 or 84, here's my second key. Go over 1 and down 1. That's your X. Squared. And I've got a minus 9 again with the X, and then a minus 105. Okay, so just to make clear, this guy is going to have really big values, right? The vertex is at a negative 108. And if you just use your regular old graph button, which is up here top right, which is what I'm going to do, but if you just use it, it's probably not going to show the parabola. Why? Because the original settings or the normal settings on your or on your graphing calculator only go from negative 10 to positive 10 on the X, only go from negative 10 to positive 10 on the Y. So I just see these two lines. I know it's a parabola, right? It comes way down here. So I'm going to do something called adjusting my window. It's this second button. This top line here are like my graphing keys. So I use the Y equals to enter the equation. I use the graph to see it, and I say, oh, I don't see my parabola. So now I'm going to look at the window. And the problem is with the Y values, right? I'm not coming down far enough. The X values are fine. I can leave those alone. But the Y values need to come down farther. So I'm going to skip over the X values. And I'm going to come down here and say, how far down do I need to go? Well, for sure, I need to go to 108 because that's the vertex, right? So I'm going to go to 110, negative 110. That way I know I'll have that vertex in there. And because this is so big, this Y scale, that's what it says, that's what it's counting by. Right now, it's counting by ones, and that's going to give me like a gazillion little hash marks going up my graph, and I don't want that. So I'm going to tell it to count by tens. You could tell it to count by 20s or 50s or whatever you want to do. All right, there it is. And we see, hey, we came all the way down to negative 110. And sure enough, this is way down there. If you want to see a little bit more of it, you can trace this guy. Hey, look, there's my y-intercept, right? X equals z, x equals 0, y equals negative 105. And if I come way over here, sure enough, down here at the bottom, I'm getting 108, right? We had a 108.375. That was for 0.75. What you need to know is in a graphing calculator like this, the pixels on the picture, it doesn't always come out very nicely. So sometimes I have to go, well, it's somewhere between there and there. Okay, and then it starts going up again. So that was my minimum. There is a way for you to calculate. So second trace for calculate, and I want the minimum. Okay, so if you're really like, I don't know what's going on here, I want the left bound it's asking me for. So I'll go to the left side of where I think the minimum is, the right side. So go over here to the right side. And then it always asks, do you want me to guess? And hey, look at that. That looks 0.75 and 108.375. So that is indeed what we thought our vertex was, right? So in this case, in case of things like this, it's nice to have your graphing calculator because it can help you check. Recently, I've had students who are telling me, oh, I use Desmos. That's fine. You can totally do that. But these are the kinds of things you're looking for. Okay. Man, I feel like this video is long, so let me look. I'm sorry. Hang on a second. Yeah, this video is getting really, really long, and I want to give you an example for you to try on your own. It's not going to be pretty. So what I'm going to do is, I used my calculator there. What I'm going to do is I'm going to give you the example. You can pause so that you can do on your own. You can pause the recording, work this problem out, see how you do, and then I'll put up on the screen for us what it should be looking like. So, I don't know why I don't have the full problem worked out. So f of x equals negative 0.25 x squared minus 2x plus 2. So I'm going to say for this one, just go ahead and find the x-intercepts because I don't have the rest of it worked out. So I'll look and see if I can find it and push pause and go ahead and work on that all by yourself. So you're looking for x-intercepts. Okay, found my notes. So here we go, x-intercepts. Here we have it. Plug in 0 for y, solve for x. I figured out real quickly this guy's not going to factor nicely, so I did quadratic formula, plug it in, solve as much as you can, simplify. Here are my two x-intercepts. If you need to, you can pause that right now and see what it looks like. The next step is y-intercepts. So pause real quickly, see if you can do your y-intercept. And here is my y-intercept. I plugged in zeros for the x's, solved it. I've got this for my y-intercept. Okay. So those two, hopefully you've done. And then the next steps are find the vertex, determine if it's a min or a max. And as I'm just putting this stuff up real quickly, you can, of course, pause as I put my solution up so that you can do that. But I'd say pause right now, do the work, find your vertex, and see if you think it's a max or a min. And here's my work. Vertex, max or min, use the formula, plug it in, get your answer for your x, plug your x back in, and get your answer for your y. I had a little typo there, a negative issue. So I think the vertex is negative 4 and 6. And then graph that thing and see what you think it looks like. You can use your calculator. And the last thing, I haven't been asking these on the other equations, but just so you know, domain and range still apply, right? So domain and range are still out there. The domain here is all real numbers. The range you have to be greater than or, less than or equal to 6. Y is less than or equal to 6. And that's because this is my vertex. Oh, and it's a minimum, right? I'm sorry. Yeah. It's a maximum. This is our first maximum here. I had it right there. So it's a maximum. So since I can't go above this point, it can't go above 6. So that's why my range is stuck down here, less than or equal to 6. Okay, so just remember all that stuff's out there. We did some of that domain and range stuff before. You have this problem. It's a very large problem. And yeah, there you go. Hopefully you worked through that one very quickly and you were okay with it. Okay, that's about it for this stuff right here. I'm just going to say that sometimes there are word problems involved in this homework. So real quickly, if the problem in the homework asks you to do something like maximize profit, if the P of x equals, and I'm just going to say negative 5x squared plus 75.1x minus 156. This is one problem in the book. Okay. If it asks you to maximize the profit, this is an application problem, a word problem, where they're using what we just talked about. So what does that tell you? This is a parabola, right? It's a function and it's downward facing. So the maximum here is going to be the vertex. So if it starts asking you those kinds of things, don't think, oh my gosh, we didn't do anything like this. Yes, we did. We want to find the max is at the vertex, right? So you need to apply the math that we just did to those problems. So just be aware that's out there in the homework. And goodness, this was a long video, so I'm going to say goodbye. Let me know if you have questions. Thanks.